A couple of days ago, I had a discussion with a student who was having some difficulty relating latitudes and longitudes and position on a map. So we did an exercise together of looking for airports based on their coordinates in the Canada Flight Supplements, and vice versa, finding an airport, deriving its coordinates, and then checking that we got them right in the Canada Flight Supplement. So I'd like to do the same thing with you. First, we'll talk a little bit about how latitude and longitude work, and then how it's practically used to find an airport or to confirm an airport position. So without further ado, out with the map and the ruler and the Canada Flight Supplement. So now we're looking at a section of the VNC chart a little bit west of Ottawa. You can see actually the line here that says VTA, that's the Ottawa VTA. So let's first talk about how latitude and longitude works. So the lines that you see here are parallel, and they're actually called parallels. They are originating from the equator, and they keep on going 1 degree at a time until they get to 90 degrees at the North Pole. And so if you can see right here, 45 degrees, we are relatively close to the 45 degree parallel. So if we wanted to locate something that is at the 45 degree parallel, we would just follow this line all the way along. But that's only one dimension. We need two dimensions to be able to locate something on a surface. So that's when we use the longitude lines. Longitude lines are not parallel. They converge on their way to the North Pole. We can't really see it in this small section, but they do. So one of the characteristics of latitude lines is that they are essentially equidistant from one another, and each one of these marks here, which marks a small amount of a degree, portion of a degree, are all the same, and each one of them actually represents 1 nautical mile. On the other hand, on the latitude lines this way, because they're converging, they're not a constant dimension. So let's see how we could use this. So if I'm at say 45 degrees north, that's pretty easy. But if I were some random area here, we'd have to express this by saying north 45 degrees, and then we need some more to be a little bit more precise. So degrees are kind of like hours. They separate into minutes and seconds. So each one of these marks that you see is a minute. So if I were looking right here, for instance, this is 45 degrees, 10 minutes, 15 minutes, 20 minutes, 25, 30 minutes. So this other large line here is 45 degrees, 30 minutes. So that's how we fill in the second number in here. The third number, we'd have to actually divide each one of these marks into 60 smaller marks. So obviously we can't do that on the map here. We'd need a much larger scale map to be able to do that. Now on the other side, in the other direction, the longitude lines start at in London, England, at the prime meridian, and from London coming towards here, we're going to the west, so west. And then if we look at the numbers here, you'll see we have 77 here and 78 over here. So the numbers are obviously increasing. So if 77, for instance, in here would define 45, and 77 would define this corner here. So that's already, we know something there, 77 degrees. And then the same idea, minutes and seconds as well. So for instance, if I wanted to see there's a little mountain in here, for instance, I could say that it is at 77 degrees, 5, 10, 15, 20, 25, 29 and a half, west 77, 29 and a half degrees. So that's how you can use positions to identify. So this little map, let's just look at that one. This little mountain or raise would be at, we said 45 degrees, 10 minutes. So 45 degrees, 10 minutes, and 0 seconds because it's pretty well on it. And then we can't measure that anyways. And 75 degrees, we said 59 minutes. Sorry, what did I say? 29 minutes. 29 minutes, and then some seconds. This may be 20 seconds, something like that. So you can see you can identify a very precise location. So let's go and look and see how we can do this with an airport here. So I have Tomville Airport here, and let's try and determine its position. So Tomville. It is, so it's not quite at 77, so it's a little bit less than 77. So 1, 2, 3, 4 minutes less than 77. So that would be west 76, of course. West 76, and then it's not 60 minutes, so it would be, let's call it 56 minutes, and then we don't know the seconds. And then now it's not quite 45 either. It would be 44 north. So 44 would start kind of down here, and we know this is 44.30. It's actually off the scale. So 44 and a little bit less than. So this is 5 less than 45. So it'd be 44.55. So I have here a photocopy of the page for Tomville, and what does it tell us? Reference 44.54, but 59 seconds. So 59 seconds is really basically a minute, so that would really be 55. And so let's compare that to what I calculated here. Yep, very close. And then west 76, 56.09, that's pretty close. So very close. So that's how we could use it in one way to find the position of something. Now, if I would want to do it the other way, I looked up, there's another airport in here, and I'll pretend that I don't know where it is. And it is, Matachan, I'll pretend. Anyway, so I pretend that it is, I don't know where it is. So it's at 45.0950. So Matawachan, and north end 45.0950. So that's really close to 50 is close to 60. So that would be, we'll make it 10 and then ignore the seconds. And then west 77.05 and 46. Again, 46 is pretty close, so we'll make that 06. So 77. So we're looking for something that is at north 45, we've identified that. 10, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Already I can have a pretty good idea where it is. And then just verify here, west 77, so 77 in here, and 05. So you can see that this is basically the coordinates that I figured out. So we can practice this with a whole lot of different airports. There's a lot of airports in Canada, so it's quite easy to use the CFS to find an airport. So my suggestion, as I will pose, is to practice it as much as possible. So another thing to note here, and just as something useful, is to know is that each tick here on the longitude lines is the same dimension, and it's the same dimension from the equator all the way up to the North Pole. And each one of these tick marks happens to be 1 nautical mile. So this distance which I'm showing here is actually 5 nautical miles, 10 nautical miles, 15, etc. So if I wanted to pick a distance, for instance, between Madawaska Valley Air Park and Kaministkeg Lake, and so I kind of take a measurement of that. Let's take just the eraser here. So it actually takes from the beginning of the eraser to this mark is the distance. So let's see, and that works out to 5, 6, 7, 8 miles. And let's verify that with an actual ruler. So nautical mile side here to here, and well, close to, it's actually 7.5 miles. So you can see you can actually get pretty accurate distances just by looking at using these numbers. Anyways, that's it. So as I mentioned at the beginning, we talked about how latitude longitude works, and we did some exercises. My suggestion to you would be to continue with exercises yourself. You can do this by taking out a Canada Flight Supplement, randomly picking some airports in your province, and then finding them on the map. I'm suggesting this particularly for those of you who might be located in a different province than Ontario where I did my exercise. Do it locally, and then you'll find that it doesn't take very long to get very familiar with the use of coordinates. Thanks very much.